Okay, good morning. Today we're going to learn about Chapter 9.3 Principles of Expansion and Contraction of Matter. So, you all have already learned about the three states of matter last year in Form 1. You all remember about solid, liquid, and gases, right? Some things to note here. Remember how solids are particles arranged very closely together? Liquids, on the other hand, they are slightly further apart, right? And gases, they are even more spread out. Another thing that we should remember that is these particles, they vibrate in their fixed position, whereas the particles in liquids, they move freely, and gases also move freely, but they move a lot faster. Alright? Okay, so we'll get back into this, but for now, let us see what the effects of heat changes or the effects of change in temperature towards certain objects, such as solid. If we were to conduct this experiment, okay, for solids, one thing is we have this gauge and a metal bar. So on normal temperature, we can actually get this gauge to fit inside here. Okay, you can put this one in here. Now, the problem now is what happens if we heat it up. Okay, if we put fire over here and heat only this metal bar. Okay, so let's say we heat this metal bar. What do you think? Will it be able to fit inside here? Okay, one thing you'll observe is after heating it up, it will be hard for it to actually fit inside this slot, because before this, when it was cool, it can actually fit exactly into this gauge. But now that it's heated up, you'll find that this metal is actually slightly, very little bit longer, making it impossible to fit inside here. Alright, now let's look at liquids. So if we have an apparatus set up like this, you can actually set this up in your own house if you want. What you do is you get a bottle, okay, and then you get a straw, put it inside the bottle, alright, and then you fill the bottle with liquid. Okay, make sure that the liquid is also in the straw. For example, let's fill it up until here. Alright, another thing you need is you'll need is something like plasticine or rubber stopper to make sure no air can come in the sides. Okay, so what can we do after this? Alright, for this since that we're using a conical flask, we can actually put it under a Bunsen burner and heat it up. But if you want to try doing it at your house, don't play a fire. What you can do is take a pot with hot water. Okay, let's make it this color, and put the bottle inside this pot with hot water. Okay, what you will see, okay, we will see that this liquid will actually increase in height, and it is also possible that it will actually flow out. Alright, now this is just the observation, we'll get into it later on. Another one, gas. So if we do the same as what we did for the straw, but instead what you can do is you take your bottle and then you put a balloon over it. You don't need to fill it up too much with air, just a little bit, that's fine. Okay, and then you put it in a hot water bath also. Okay, so what you'll find is that this balloon will actually expand, right? So this balloon, let's use different color, it will actually expand. Right, in all three cases, you can see that when we add heat to the object, whether it doesn't matter whether it's solid, liquid, or gas, it will expand. For the gas, it actually increases in length. For the liquid, it increases in volume, and the gas inside here, it expands in volume also. Alright, now what is it, how is it related to this, the three states of matter? Have a look. Remember how we talked about the particles vibrating in its fixed position, whereas the gas and liquid will move freely? If when a solid is heated, the particles vibrate faster and move further apart from one another. Okay, they were in a fixed position, but when you heat it up, they vibrate further. Okay, this causes the volume of the solid to increase because the solid expands. Conversely, when the solid is cooled, the particles vibrate slower and move closer to one another. This causes the volume of the solid to decrease, and hence the solid contracts. Now, for gas and liquids, on the other hand, we know that the particles move freely. So when the liquid and the gas are heated, the particles move faster and randomly. The distance between the particles also increase. Therefore, the volume will increase. Hence, we can say the gas expand. Gas or liquid expands. And the other way around is the same. So, in all situations, okay, for solids, when it's cold, the particles are closer together. When it's hot, the particles are further apart. Therefore, we can say that it expands when it's hot and contracts when it's cold. Similarly, for liquids, we have when it's cold, it's closer. The distance between particles are closer, and when it's hot, it is further. Hence, we have it expands when it's hot and contracts when it's cold. Similarly to gas, you get far and even further when hot and cold. Alright? So, what are the uses of this expansion in our daily lives? You guys should be familiar with the mercury thermometer, or in this case, alcohol thermometer, because almost all thermometers nowadays in our labs are alcohol, because mercury is very toxic. So now, what happened is, the liquid alcohol mercury inside here, initially it is, let's say, up to here, alright, at room temperature. Okay, so if we heat this thing up, we will notice that this will increase. So basically, the thermometer, the mercury or alcohol inside the thermometer will expand or contract depending on the temperature. Another example is railway tracks. Alright, if you see the railway track, if you actually go to anywhere that has a railway, and you can see that it is not just stuck together. There's a tiny little gap. Let me show you a picture of it, like this. There's a tiny little gap over here. Why? Because during a hot day, what happens is this metal will expand. This metal also will expand, and hence they expand according to the length. This one wants to go here, and this one wants to go here. So if you have a small gap, you actually allow them to expand just a bit, and then no problem. What happens if you don't have this gap? It can lead to situations like this. This is what we call buckling, where it expands so much and there's not enough gap that the forces of the expansion of all of this will cause it to bend out of shape. And you can imagine if a train is supposed to come, what will happen? Of course, can lead to very big disasters. Another example is what? Your bridges. So steel bridges are built with rollers and gaps on the end. This allows the bridge to expand during hot water. Have you ever seen this thing? Like if you go through the bridge, like any bridge on the road, sometimes you'll notice that there is like this structure. What is this for? It is to allow the concrete and metal to expand in its length. There's a small gap so it can actually move. If not, what will happen? If let's say there's no gap, what will happen is this bridge may actually bend out of shape. Alright, there's a very good video that I'm going to link along with the assignment, and I want you guys to watch that for further explanation. Another example will be your electrical power line. So you ever notice or not? During the day, you always see that it is sagging. All of these lines, they are sagging or they are not straight. Why? It's because these lines will expand and contract according to temperature. So it is actually very important to install them. If you install them on a hot day, you need to make sure they are not straight, okay? Because if the line is straight, let's say for example over here, if installed straight during the day, what will happen at night? What do you think? At night, these wires will want to contract, okay? So they pull against each pole, and what happens? You get the pole bend towards wherever the wire contract. And if you think like this situation, like 2 poles is bad enough, imagine if you have hundreds of poles connected, and then you have a lot of poles broken or fallen because of the contraction. Therefore, when we install telephone wire or electrical wire on poles, we have to account for expansion and contraction. Now, for the last example is a bimetallic strip used in alarm. So, in this case, the fire alarm is actually in this circuit, right? Where you have the battery all connected, and this will act as a switch, whether it's on or off, okay? So, to make sure it's on, what happens? We need this thing. We need this metal to touch here. Then it'll be on, and then the fire alarm will ring. But how do we get this thing to work? Right. So, this concept comes from the idea where different metals or different material will expand differently, okay? We call it the expansion coefficient, but you don't need to worry about that. You just need to know that in our case, copper expands more when heated than iron, okay? So if let's say you heat it in this situation, copper expands a little bit more, and since that these two are joined together, what happens is it will bend. The shape will bend downwards because the iron is below, okay? So in this case, if copper and iron here, see, let's say if there's a fire, what will happen is this part will want to expand, but this part does not expand as fast. So what happened is, we will get this metal expanding more, this one expanding less, and expanding more, so we'll end up with a bend. This strip will bend towards this side, and when it reaches here, the circuit is complete, so electricity is sent to the fire alarm and it'll ring. Right? So, what are the uses of this principle of expansion and contraction of matter? Very easy. Sometimes, remember, if your bottle is too tight, what can you do? You can actually submerge the bottle lid, especially if it's a metal bottle, like for example your chili or your tomato sauce. Okay, try submerging the bottle lid in hot water for a few moments. Alright, another thing is, if you have running hot water, you can actually run hot water over the lid here. Make sure you don't get the container hot, otherwise the container will also expand. So this is what happens. Before, when everything's cold, you will see that the lid over here is very tight and very close to the bottle. But however, if we heat it up, the lid will expand a bit and be not as tight, so it's easier to open. Another one, very simple and very common example is your ping pong ball. Remember how sometimes when you play ping pong, the ball will get squished? So what you can actually do is put it in hot water, and when you put it in hot water, what will happen inside the ping pong is the hot water, the gas inside will expand, and when it expands, it will actually push this ping pong ball that's dented, push the shape to be round again. Okay, and that is all for 9.3. I want you guys to do the assignment that I've assigned to you guys, and as always, I hope you learned something today. Thank you.